Okay, solving equations is really nothing more than just moving things around the equal sign. We're going to do things really slowly at first, but hopefully over time and with enough practice, this becomes secondhand and you're not going to make as many mistakes. But for now, let's go really slow. I want to solve each equation for the variable x. So I want to get this x by itself. Right? I'm looking for, after a bunch of algebra, x is equal to something that doesn't have any x's in it, right? Like x is equal to 7 or x is equal to 3, something. So whenever we're solving for x, it's like peeling away the layers of an onion. What's being done to x and how do we undo it? So right now it's being multiplied by 2. So I can multiply both sides of my equation by the multiplicative inverse of 2, right? Because it's being multiplied by 2. So the multiplicative inverse of 2 is 1/2. Now I can't change things willy-nilly. If I multiply the left-hand side by 1/2, then I also have to multiply the right-hand side by 1/2. Right? So I really just copied down this 2x is equal to 6. And I did the same thing to both sides of the equation, so I didn't change anything. And now the reason that we did that is because now, because of associativity with multiplication, I can do the 1/2 times the 2 first, which just gives me a 1. My right-hand side simplifies to 3. And 1 times x, 1 is the multiplicative identity. So this is now just equal to x. So x has to be equal to 3. Now, when you actually solve equations, I'm going to prefer that you don't do it like this, where you don't actually write out the steps. If I give you the equation 2x is equal to 6, you don't need to show me that you're multiplying both sides by 1/2. You just need to show me the consequence of you doing that. So when I write down 2x is equal to 6, I think, how can I move that 2 to the other side? Because I want to get x by itself. So I divide both sides by 2. If I divide my left-hand side by 2, I get x. If I divide my right-hand side by 2, I get 3. So this is really going through all the details, but in your work throughout this class, I want your work to look like this. Don't show me what you're doing, show me the consequence of what you're doing. Let's do the second one. I need to solve for x. And again, like peeling away the layers of an onion, what's being done to x? And we need to take that away. So before I worry about this x minus 3, whatever that is, it's being multiplied by 7. So how do I get rid of multiplication by 7? I divide by 7, or I multiply by the reciprocal. All right. By associativity of multiplication, I can do the 1/7 times the 7, which gives me a 1, which leaves me with just 1 times x minus 3. And 15 divided by 7, let's just leave that as a fraction. All right. By multiplicative identity, 1 times x minus 3 is just x minus 3. And now what's being done to x? I'm subtracting 3. How do I undo that? I add 3. And again, by associativity, this time for addition, I can do the minus 3 plus the 3. Over here, let's leave that right-hand side alone. Right? If you're not ready to deal with something, just leave it for the next step. You can go as slow as you want through these equations. 0 is the additive identity, so x plus 0 is just x. And now I think I'm ready to deal with that right-hand side. So I need a common denominator. The common denominator I'm going to choose is 21. Because that's a multiple of 7 and 3. I can write 15 over 7 as something over 21 by multiplying top and bottom by 3. That'll be 45. And I can write 3 as something over 21. What's 3 times 21? 63. So now that I have a common denominator, 45 plus 63 is 108. Cool. So we figured out what x had to be. And again, whenever you're solving these equations, I don't want you to go through all this work. I want you to think about things as moving them around the equal sign. So how do you get x by itself? You need to get rid of that 7 first. So divide both sides by 7. Now what do you need to do? You need to add 3 to both sides. So don't show me that you're adding 3 to both sides like we did over here. Just do it. If you add 3 to both sides, your left-hand side is now x. Your right-hand side is now this. And you can see it spits us out at exactly the same point. You're still going to find that x has to be 108 over 21.